Hey everybody, how's it going? So I thought we'd do a quick little beginner CNC project using Fusion360. So this is going to be, like I said, a beginner project. So if you're a seasoned pro here, probably move along. But if you're new to the game of hobby CNC, then maybe stick around, especially if you're new to Fusion. This will at least get your feet wet and get you started with a nice, easy project to get you going. So we're going to do a nice little 2.5D cutout of Texas here, using just some scrap stock that I have laying around. I did mine in oak. You can probably do this in just about anything. Oak's a nice, hard wood. You get pretty clean cuts with it. And so this is how it turned out. Again, nice and easy. It's nothing fancy here. This is a single tool, single setup. About an hour-ish project, a little more than that, maybe about an hour or so. So I'll show you how to bring in a model, how to scale it in Fusion, how to set up, do your setup in your manufacturer workspace, and then set up your toolpath, and then how I exported it for my machine, which is a little Genmitsu 3018 Pro, right? The SaintSmart 3018 little hobby machine. But anyway, so like I said, it's a little 2.5D relief or topographical map of Texas here. So as you see, I'm here in the manufacturer workspace, and this is how it'll look once we simulate the toolpath and how it's gonna come out. But before we jump too far ahead, let me close that out. Why don't we jump into the design workspace now that I've touched something and locked this thing up. Okay. So why don't we jump over here to the design workspace, and you'll see, so I brought in this 3D model of Texas from Thingiverse, and it's got lots and lots of, it is a pretty smooth, detailed map, and it's exaggerated in the Z, which is kind of cool. Obviously in Texas we don't have any big old peaks like this, so it's been exaggerated in the Z. Which really helps when you want to do some of this 2.5D topographical stuff. Now you can do the next step, which we will maybe in a later video, of setting up an additional toolpath, which will be your finishing path, using a different bit to actually get a lot of these real fine details. But for now, like I said, this is the beginner setup. So, so to bring in your model, obviously you need to model, so go get it off of Thingiverse. I grabbed Texas. You can grab, there's one out there that has all the states, so grab whatever state you choose. And you download your model, and when you need to bring it into Fusion, you're going to go insert and insert mesh. You'll go to wherever you've downloaded it, select it, hit OK, bring it in. And then you need to figure out how big it is. It doesn't really tell you right off the bat how big it is. You need to do some inspection. So the nice thing, you go to the inspect button there, and we're just going to do a simple measure. So I'm gonna grab this little left corner, and I'm going to go to the farthest right corner, and I'm at 69, just under 70 millimeters. Now when I originally brought this thing in, it was about I think it was 200. So for simple math, we'll just say it was 100 millimeters when it came in. And I'm going to do top to bottom here. So if we just grab the top corner and this bottom corner, so you can see we're 73-ish millimeters. So I needed to get it down from 100 millimeters down to basically 75 by 75 is the target I was shooting for. And you can't really do that while you're in the design space here. If you go to modify and scale, there, you can't do anything because this isn't a body or a component that you've made in Fusion, right? You've simply imported a mesh. So you need to be in the mesh workspace to do that. And the easiest way to do that is that here under your bodies, right click on mesh body and go to edit. And so now your design space has changed to your mesh, and now you can do some simple modifications to this. You can't do anything really crazy with this, like adding features or adding holes or things like that. You can do that, but you have to convert the mesh, and that's in a different video. But all we're going to do here is scale this. So you go to modify and scale, and you select your entity, right? It's telling you what do you want to do. So I'm going to select the entity, and I'm going to do either a uniform or non-uniform scale. So uniform means whatever I do, it's going to affect it in all axes and non-uniform means I can just do it in the X, just in the Y, or just in the Z. It just depends on what you want to do. In my case, I did uniform, and at 1.0 that means it's 100%. So it came in, let's say at 100 millimeters is 100%, and I wanted it 75 wide-ish, so I went 0.75, dropped everything down and brought it into the size that I wanted. So this might be a little trial and error for you. You can grab the calculator out and figure out what percentage you need to reduce this to get it down to the size you want, but that's how you do it. I'm going to escape out of this because I've already got it done for purposes of our project there. So when you're finished here, you just go back over to you click Finish Mesh, and you're back in your normal solid design workspace. And from here you can pretty much go straight to CAM, or your manufacturer workspace. There's nothing really else to do in the solid workspace here. So if we go to manufacturer, first thing you need to do is do a setup. I've obviously already done one, but what you'll be doing is you'll click this setup button, and that'll create you a new setup. I'll edit mine so we can see here. So the first thing you're going to do is on the setup tab is pick your machine. So you're going to go select. Now I've got, like I said, a little 3018 Pro. It doesn't show up in Autodesk list of machines, so you pick this generic 3-axis mill. My operation type here is milling. I'm not turning or cutting or doing any additive, just milling. My orientation is my model. My orientation, or my origin, is my stock box here. So I'm picking a point on my stock box for my home, and I've chosen this bottom left corner. Now you can choose the middle, you can choose the top, wherever you want your home to be for your tool. This is essentially what you're picking. So I'm picking the top left corner of my stock. And then your model here is your mesh, so you'll pick that and you'll select the actual model. In the stock setup, I've chosen a fixed size box. Again, my stock is it's basically a 1x4 piece of oak. It's an oak plank, so it's not really 1x4, right? It's 90 millimeters by about 20 millimeters or 19 millimeters, so it's 3/4. So the nice thing is when you put in, like if you put in 90 millimeters here, 20 millimeters there, Fusion does the conversion for you. So I've chosen my X at, now remember my left to right here came out to be about 73 millimeters, so I've gone a little bit wider here at 90, or 3.5 inches there, 3.5 inches on the Y, and I've chosen about 1/4 inch or 3/4 of an inch tall, so that came out to 19 millimeters or 0.74 inches. And your model positions here, where do you want your model in relationship to your stock? So if you see model position in the X, I centered it. Can't see this. Centered it here. Model position in the Y, so top and bottom, I've centered it. And then model position offset from the top. So if we change our orientation here, I didn't center it like the other ones. If you center it, now you're centered here in the stock inlet, which means you're going to be chewing away all of this before you actually get down to your model. You can do that if you want. I chose not to do that. That's a whole lot of machine time, and I wasn't not gonna buy me things. So I said an offset from the top, and I said 0, which means the very tippy top of the model is right there at the top of the stock. Now you can leave yourself a little bit of like a 20 thou offset if you want, and then that way you're tooling down just a little bit before you actually start your cutting. Totally up to you. I chose 0. That made it easiest. And so here you've got your overall dimensions of your stock box. So if I come back out here to home, right, at 3.5 by 3.5 by 3/4. Under the Post-Processing tab, there's really nothing you need to do here. If you want to name your program, you can, but otherwise you have the opportunity to save the name of this file when you're post-processing. So that's really all you need to do under your setup. So I'm going to cancel out here. And now you want to do an adaptive toolpath. You'll under here, so when you're selecting your setup, you'll go to 3D and adaptive clearing, and that'll bring you into this space. So first thing you need to do under the tool is select your tool. What are you going to use to cut? I used this 3.15 millimeter flat end mill. So if your tool doesn't show up on their list, which if you're using like a 3018 like I did, it's not. You're going to have to define your own, and it's not hard. The best thing to do is to grab your tool, grab your cutter, and actually measure it. This is a very simple thing where it walks you through the process of what to measure, so that you're telling Fusion exactly the dimensions of your tool, so it's not running into walls, or you're going to get what you expect to get, or whatever the software's telling you you're going to get based on the tool dimensions that you're putting into it. So again, I used a flat end mill. I chose to do millimeters, and like Fusion's really good at saying, well, if you don't have to do everything always in inches or everything always in millimeters, it doesn't matter. It'll do the conversion for you, and you'll see as I put in what my step downs and feed rates and things like that, it's going to do it in feet per minute or inches per minute or inches per second, even though I'm telling it to do it in millimeters. It doesn't matter. It's doing the conversion, which is really nice. So flat end mill, millimeters, 3 flute. The diameter, so the easiest thing, like I said, pull out the calipers and actually measure the tool. So mine was 3.15 millimeters. That was the shoulder length, the flute length, the total body length, and then the overall length of the tool, and then the shaft diameter. Under your feeds and speeds, I pretty much left things at the Fusion360 defaults, because you can always change them over here in your feeds and speeds. As far as like your RPMs, and then your feeds and speeds will change dynamically, and then you can adjust based on some trial and error if you want. And again, you can post-process with some things here if you like. I left it all at defaults and didn't even mess with it. So once you've got that selected, your tool then shows up here. I don't have coolant, so it runs disabled. Instead of the 5,000 RPMs, my max spindle speed I think is around 8,000 RPMs. So I modified that to 8,000 and modified my ramp spindle speed to 8,000, and that will change your surface speeds and your cutting feed rates and things right there. Again, you can change these if you like. So if the tool is doing a lot of jumping, if it's having a hard time getting through your material, then you're running too fast, then I would change your cutting feed rate to something less. So this is almost 40 inches per minute. And depending on how much step down you have, could be okay. Your step down and your step over. This ended up being fine for me. Nothing here in the shaft and holder that you have to deal with. If we go here to the geometry tab, I'm telling it to do a bounding box around my model. And I told for tool containment to keep the tool on the outside of the boundary. You can keep the tool on the inside or on that center line, whatever you want to do, but it's basically just telling you where do you want to keep a tool in relationship to this line. Stock contours I have it checked, but I have nothing checked, so either way it doesn't matter. Rest machining doesn't matter in this case, because rest machining means you don't have any previous operations for this to run off of, so rest machining kind of doesn't matter in this case. Nothing for tool orientation on model. Under your retraction heights, this is just basically, so if you think about if you're from the 3D printing world, when you're retracting, or if you're doing a Z-hop, it's how much is your tool holder going to move up and out of the way. So I've left everything pretty low. Defaults in Fusion are pretty conservative. Wants to really make sure that that tool is not going to hit anything. This is a small workpiece that's not moving around a bunch of geometry, so I left everything pretty tight. So the less retraction moves and the less distance it has to run, the less machining time you actually run over. So I left everything at about 100,000ths of an inch across the top. Stock height I left alone, bottom height I left alone. Really this retraction height and this clearance height, these are the two things that it's really talking through. Under the passes, I left the tolerance alone. I did check both ways, so that means the tool is going to be moving in both directions, not just in one direction. I told it to machine cavities. The direction was conventional versus climb. And then my maximum roughing step down I put at, so that's a 1/16 of an inch. So if my bit is an 1/8 of an inch, I told it that the biggest step over it could do was a 1/16 of an inch. and from a step down perspective, so when it steps down to the next layer, the maximum I wanted to cut into was a 1/16 of an inch. Now, to get these nice kind of big stair-step patterns in the model, the big thing here is the stock to leave. So I left this at about 20 thousandths, and so what that means is the stock to leave around all of these features. Now, if you leave this at 0, it's going to try and machine out every single one of these little peaks and valleys with your big 1/8 inch end mill, right? Big, relatively speaking. So if you say, well, leave a 20 thousandths stock around all of these features, that's where things start to flatten out. It's just going to mill out the big step and then come down into another big step and then another big step and another big step. So you can really start to play with how much detail you get out of the tool with this stock to leave. It's not all of it in there, but that plays a big part, especially in that step down scenario that we're going after. And then as far as your linking, in this retraction policy, I said minimal retraction, preserve rapid movement. I wanted to just go as fast as we could, stay down level least, ramp type helix, and really that I left everything else at defaults, nothing else happened there. So once you've got that, you'll have to generate a toolpath, and it'll start that automatically once you hit save. It'll go through this process of identifying all the toolpaths. You can see here where it's ramping down and moving around. So why don't we just go through, if it hasn't generated for you already, you'd right click on your adaptive and say generate, and then when it's done, you hit simulate. And so you have your tool and your stock here. So if we hit play, you'll see here it starts to move down. And if I speed this up, you can see that first sort of step over to the left, and then another step down, and as it's cutting away. Now if I slow this down just a hair, you'll see what it means between both ways. We're back on the adaptive clearing setup when we said you can have it just cut one way or both ways. So you see the tool's moving in both directions here. It's cutting in both directions. The other option is if you have it just going one way, then it makes the pass, it retracts, comes back over, it makes another pass, retracts, comes back over, it makes another pass. So for my purposes, for this project, to do something quick, I had it run both ways. Probably not the most optimal tool to run both ways, because the flute's really just running, the cutter's really turning in one direction, but for our purposes here, it worked out good. So if I speed this back up, over here on the side as it's going, so you can play with this a bit and say show the tool or not. You can show tool paths or not, show the stock or not, which I kind of like, and then you can play with how that stock looks by changing some of these settings. And then statistics is really about the time. So machining time, it says it's a little over 30 minutes, and it's machining 92.916 feet. So just fair warning, I don't know why. It has something to do with the feeds and speeds and probably limitations of how fast my machine can go versus what Fusion thinks how fast it can move. But my experience has been double this, at least. Whatever you get here, double it. Now, that's for my machine. Again, I've got that little 3018 Pro. It is not the fastest guy out there on the planet. It is not belt driven, it's lead screw there, and it's in general it's a slow machine because it's a beginner machine. So if you're running the same setup, whatever Fusion's telling you is here, I would at least double it, just to set your expectations right. And then that's it. Oh, that's not it. So then when we're done here and you like what it's doing, you come here and you say post-process. When your post-processor window comes up here, come on, a little slow. It's coming, it's trying. There we go. Where did it go? So this post-processor, for mine it was gerbil, generic. that's what I picked. You can pick a location, and when you say post, you then select. So if I call this Texas 3D, you're going to save this out. It's going to come out as an NC file, and then you can put this out to your controller, whatever controller you're using. So I use the offline controller, so this goes onto an SD card, and then into my offline controller, I set my home and run the program. So anyway, again, this is how it came out. I think it came out pretty good. Definitely room for improvement, but that's the point. It's a beginner CNC project. So anyway, I hope this was worth it to you. I'll likely have some more coming up. So thanks again. See y'all.